Hey everyone, before I start this video proper, I'd like to mention that the content for this video, and in fact for all the videos until the end of the integration technique series, will only be found in the H2 Math syllabus. As such, for those of you taking O-level A Math or H1 Math, you guys can actually proceed to the integration application series already. But for those of you considering taking H2 Math in JC or are looking to practice for H2 Math, you guys can use this video as a form of a refresher or as a taste of what integration could look like in H2 Math. Nonetheless, let's begin. We continue with trigonometry integration, and we're looking at the four remaining singularly powered trigonometries, which are secant x and tangent x. And the next pair, well, the last pair, cosecant x and cotangent x. So you notice I grouped them again like differentiation, right? Secant x and tangent x and cosecant x and cotangent x. You see why I grouped them together again. The good thing is that the integrals of these four trigonometries are found in your MF26. So I'm just going to write them down. So for secant x, you get back ln secant x plus tangent x, and obviously not forgetting your model sign and your plus c. For tangent x, you get ln secant x and plus c. So you notice already for the first pair, it's like your differentiation, right? Secant and tangent are partners. So in integration, we see secant x plus tangent x with the ln. For tangent x, you get ln secant x. For cosecant x, is actually the same, right? Ln cosecant x plus cotangent x. The difference is that there's a minus sign in front of the ln. Same thing for cotangent x, there's some slight differences. It's just ln sin x plus c. So it's not ln cosecant x, unfortunately. So I won't be proving secant x and cosecant x because they're quite complicated to prove, but you can kind of verify the results by differentiating the derivatives, by the integrals. Though I'll show you the proof of how we obtain the integrals of tangent and cotangent. So we have tangent x, right? It's rewritten as sin x or defined as sin x over cosine x. So we know that the opposite of integration is differentiation, right? So we must kind of find a form where we can integrate this. First, you notice that the numerator is the derivative of the denominator, right? We have sin x being the derivative of cosine x, obviously missing the minus sign. So this is almost the form of f prime x over fx, right? So if we recall in differentiation, what derivative or what formula when differentiated would give you f prime x over fx? It would be the ln fx function, correct? As such, if we were to integrate tangent x, you'll be integrating sin x over cosine x, correct? Which means we'll be obtaining ln cosine x first, right? Because fx is the bottom, right? For when you differentiate ln fx. However, we're not done yet. The derivative of cosine x is minus sin x. As such, we have to add a minus sign in front to eliminate the minus sign from minus sin x to become a positive. Because of this minus sign in front, well, based on the law of logarithms, I bring the number up to the power of cosine x, and I obtain cosine to the power minus 1, which equals to 1 over cosine x equals to ln secant x. Same logic is applied to integrating cotangent x dx. I rewrite it as cosine x over sine x, which is also actually, now it's directly f prime over fx, right? The derivative of sine x is cosine x. As such, the integral is simply ln sine x plus c. So there we have it, the integrals of tangent x, cotangent x, and for me that I won't be proving secant x and cosecant x as well. Hence, we have this general formula for which fx is of the form ax plus b, and that a is not 0, otherwise it will just be a constant. So we have y. So we then have secant fx, tangent fx, and the final pair cosecant fx and cotangent fx. So the integrals, well, it's basically the same, just that to divide by the derivative inside. So we have ln secant fx plus tangent fx plus c Then don't forget the divide by the derivative inside. 1 over a ln secant fx plus c for the integral of tangent fx minus 1 over a ln cosecant fx plus cotangent fx plus c. And finally, we have 1 over a ln sine fx over sine fx plus c. There we have it, the general formula for the remaining four singly powered trigonometries.